in SynthMaker, you have different types of data values, similar to in programming. So you have doubles, ints, and floats and booleans. And here I'm showing the 4 types. I will start this from scratch, so I can explain as I create components and connect them. But you can see here some ints, some doubles, some floats, and some booleans. So when you're playing notes, these types are all useful. Okay, so if I start, I'm going to close this schematic and start again from scratch. And I'm going to create a sine synth and connect it to computer keyboards. As always, key to MIDI, and now audio out. Okay, so we can hear some sound. Now I'm going inside the sine synth, and that's our synth. Okay, so you see here these purple connectors. They might change color, but for now they're purple. This is all compiled code. It runs C functions. So, and the ones with a square, they represent 16 values. F for float, the dot is a boolean, I is an int, and you also have a double, which normally you don't use the double because it takes, while the 16 floats can be processed in one go, with doubles you have to do it twice. So not so good for performance, and you don't always need doubles. Most of the time you don't. One situation in which you might need doubles is with, for example, time, because when you're counting the time of your note since you since you press it down, so when your gate goes up, this time might need to be very precise, especially if you're doing a table lookup on an interpolated like audio file. You need the subsample precision, and that's at the moment this time is the only place where this double is being used. So the float is 32 bits, double is 64, so it has a lot higher precision. The ints are 32 bits, and booleans is also 32 bit because it's often used as a mask. So all the 32 bits all go to 1 or all go to 0. Okay, so when you want to display these numbers, there's this in the display section, there's this show components. You see show bools, show doubles, show floats, show ints. So I'll start, for example, show floats. You see here 16 numbers because there are 16 voices running simultaneously in parallel. So, like I said, these square ones, they represent 16 numbers. I'm going to show the labels of the MIDI to voices. So we have a frequency coming out there. So when I play notes, you should see so when you release your note, these frequencies stay in place, because you might have oscillators that need to run even when you're not playing a note. They could be doing modulation. So that's why you see them staying. So these are frequencies. You might want to see them pinned on the right side. And so if you select it, you can pin it, and then you can see it there, and also give it a name. Frequencies. You can now see the name there. So if I keep playing, the frequencies keep changing. You also have, you can also type a number by hand. Here in the math section, you have a C float. And you'll see, if I connect these to showing the frequencies, which now are not frequencies. Now it will show what we type here. And when you type it by hand, all 16 are changed. So I'm going to go back to the frequencies. Okay, so for gates, it's a similar thing. You would show booleans and display show bools and connect there. And now you can see the gates when it's on and when it's off. I'm going to also name this one gates and add it to pin it to the right side. Okay, so pitch, I was showing frequency, but you can also see pitch. Pitch is basically the same as the MIDI note, but it's a float value because you might, it's often used for modulation, or you can detune it. And the note, this one, is the same as pitch, except it's an int. This will be used, for example, for when you have waves, like for drum sounds, you might want to use this note to select which wave to play. And I'm going to do now show ints, and you'll see that they're the same. These are notes. Pin it to the right side, and you'll see they'll be the same as the pitch on top. So this one now is pitch. And I'll make it bigger to make it more. So you see they're the same. Pitch and notes are the same, except for the type of data, which one is float, the other one is int. Now time will count the time for each note, so it needs a gate. Okay, I'll connect to there, and I'm going to do show time, show doubles. So if I plug this here, and I'm going to name this one time and pin it, make it a little bit bigger. And so now you see when you press on a note, I'll zoom on it, you can see the time. It keeps counting the number of seconds that the note is on. And yeah, so basically these are the four types. You have ints, you have doubles, you have booleans, and you have floats.